Welcome to our lesson on functions. So in this lesson we will be solving more examples on modulus functions. Okay, so let's start. Now we have a question as this: the absolute of x squared plus 1 is equal to 10. All right, so like I said in our previous videos, all that you have to do is to equate x squared plus 1 equals 10 for the first part, and then the second part you equate x squared plus 1 to negative 10. Okay, so that is it. Let's start. Okay, so this is the first part. We equate it to 10, and then we solve for x. Okay, now 1, this plus 1 will come to this part to become negative 1. So you have 10 minus 1, that gives you 9. All right, and you take square root of the 9, and x will be equal to plus or minus 3. Okay, so plus or minus 3. All right, now what you do is that you test your answer. By putting the values of x into this function to see if the answer will be a positive 10. Okay, so let's start. If I put positive 3 into this function, positive 3 squared is 9, and 9 plus 1 is 10, and the absolute of 10 is 10. Okay, so the positive 3 is true. We are going to accept it. Now when we put negative 3 into this, we have negative 3 all squared, and that will give us positive 9. Okay, negative 3 squared will give you positive 9. All right, so plus 1 is 10, and the absolute of 10 is equal to 10. Therefore we are accepting both positive 3 and then negative 3. All right, so let's go and solve for the part B. Okay, where we are going to equate x squared plus 1 to a negative 10. Okay, so we equate to negative 10, and then we solve for x. All right, so this will give us x squared equals negative 11. So at this stage what we do is that we take square root of negative 11. But this video is not for A-level mathematics. Okay, it's for IGCSE and then for WASI. Okay, so we do not treat complex numbers with you. So what do you do at this stage? All that you have to state is that since the square root is undefined, there is no solution. Okay, but when you do A-level mathematics, then you will use complex numbers to solve this. Okay, so I will not talk about complex numbers in this video. All that you need to do is that when you get to the negative number and you're about to square root it, just state that there is no solution. Okay, that would mean that the answer, when we solve this, the answers that we will get is 3 and then negative 3. All right, so this is a second example which is a bit different from the first one. The first one, this was a constant. We had 10 there, and now it is x. But the good news is that it follows the same trend. Okay, so first we equate this whole thing to x, and then the second part of it we will equate this whole thing to negative x. All right, so let's get started. So we will equate it to the positive x, and then we solve for x. All right, so just move this to the other side so that you get negative 6x here. Okay, all right, then is equal to 0. So we will factor out x. Now when we factor out x, this is what we have. It means that x is equal to 0 or x is equal to 6. Okay, then we will do testing for both the 0 and the 6 to see if they truly satisfy the equation. Now when you put 0 into the modulus, then you expect your answer to be what? To be 0, isn't it? Because x is here, so in place of x you put 0 there, and that is what we do. So put 0 here, put 0 there, put 0 here. What we are expecting is that the inside will be 0 as well. Okay, so let's see. All right, so the inside is 0, and the absolute of 0 is 0. Hence 0 is true. We are going to accept it. Then we will test also for 6. so you put 6 into the modulus. Now what you are expecting is that the inside would be 6, okay, or will be -6, so that the absolute of it will still be 6, okay. And the inside, when you simplify this, you have 6, and the absolute of 6 is 6. Hence we are going to accept both 0 and 6 as the answers to this modulus function. All right, but since we have already tested for the 0, we move on. All right, so we move on. Okay, so we have this function. Well, at this stage we would want to consider setting this whole thing to the positive version of this. Okay, that's what we will do. And the b part, we will set this to the negative of this, and then we are good to go. So let's solve for x. Okay, so we expand and then we group like terms. This is what we have. You solve this quadratic, and then you have the root as -2 and then 3. Okay, so what do we do with this? We test. Okay, so let's test it. When x is -2, that is when you put -2 here, what do we get? So this is what we are having. Okay, so the point is that when we evaluate, we get 1 here, and this is also 1. That would mean that -2 is correct, and we are going to accept it. Okay, then let's test for 3. So we put 3 into the function, and then what do we get? We get 6, and the absolute of 6 is also 6, so that is also true. So let's go and check for the part B. Okay, so the part B, that's the second part. I told you we will set this whole thing to the negative of this, so you just put it in a bracket nicely like this, and then you negate it. Okay, then you expand. All right, so distribute this negative over the bracket, and this is what you have. And then you group like terms, you get a quadratic like this. Okay, then you factor x out, and then you solve for x, and you have x to be 0 or -1. All right, so what do we do with them? We test. Okay, so let's test. When x equals 0, that is when we put 0 into this function. What do we get? All right, so this is what we have. We have the absolute of -3. Okay, and then on the right hand side we have 3. But is the absolute of -3 equal to what we have here? The answer is yes, so we will accept 0. How about 3? So we test for the -1. So when we do that test, all right, so -1, when we do that test, we have -2, but the absolute of -2 is equivalent to what is on our right hand side, so we are also going to accept -1. All right, so we have our fourth example. Okay, so this is the same trend. We are going to equate this to the positive of this, and then later we equate this whole thing to the negative of that. Okay, all right, so let's do that. So let's group like terms, and then we have this. Okay, remember that this part will be 0, so let's factor out x and then solve for the root. So we have x equals 0, and then we have x equals 6. Then we do the test. You always have to do the test. Okay, so let's test when x is 0, and then this is what we have. Okay, and then what do we get? The absolute of 6. Is that equal to 6? Yes, it is, so we are accepting 0. How about 6? Let's go and test for 6. All right, so when we test for 6, we are getting 0, but is the absolute of 0 0? Yes, so we are also accepting 6. Then we do the b part, where we are now going to equate this to the negative of that. Okay, so we have the negative of this, so we will expand this. Okay, so you get -6, but now be careful, negative times the negative here will give you positive. Okay, all right, then we group like terms, and then we set up our quadratic nicely like this. Okay, then we solve for the roots of this. We do that. When we solve for this, we have this, and this will give us x equals 2 or 6. Now what we are left to do is to test whether we are going to accept or reject them. So when x is equal to 2, what do we get? We get -4 in the absolute sign, but the absolute of -4 4, yes, hence we are accepting it. Okay, so let's test for when x is 6. What do we have here? We have 0, but the absolute of 0 is 0. So since the left hand side is equal to the right hand side, yes, we are going to accept it.